90,000 years ago, in a cave in the mountains of Siberia, a 13-year-old girl died. She was buried in silence, in a cave floor that would not be disturbed again for tens of thousands of years. When scientists finally reached her in 2018, they did not find a skeleton. They found a single fragment of bone, smaller than a thumb, and when they read what was hidden inside it, the discovery stopped an entire field of science in its tracks. She was not Neanderthal. She was not fully anything researchers had ever named before. Her mother was a Neanderthal. Her father belonged to another kind of human entirely, a population barely known to science, called the Denisovans. She was, and remains today, the only first-generation child of two different human species ever confirmed to exist. Somebody carried her, somebody fed her, somebody kept her alive for 13 years, in an Ice Age wilderness where a single mistake meant death, long enough for her to become a teenager before the world took her. If a child like her could be born once and survive that long, she was almost certainly not the only one. Now travel 2,000 kilometers southwest, to a hillside above the Mediterranean Sea. There, a different child lies buried, this one perhaps 5 years old. Her body folded gently, deer antlers laid across her chest, by hands that could not save her, but refused to let her go unmarked. And nearby, in a cave carved into the same limestone ridge, lies a skull that has confused scientists for nearly 100 years. A child's skull, with a jaw that leans one way and an inner ear that leans another, caught, some researchers believe, between two different human worlds. This is the question this documentary exists to answer. Did Neanderthals and modern humans, two separate branches of the human family, ever raise children side by side? Not simply cross paths in a valley and move on. Raise them, nurse them through fever, watch for danger through a freezing night, bury them with grief when they died too young. For most of the last century, science insisted the two groups were strangers, rivals at best, and the honest answer to this question was that we could never know. Bones do not explain who held a child through the cold. A skull cannot say who sang to her, if anyone sang at all. That certainty has collapsed in the last 2 years. New excavations in Israel and Turkey, a re-examined bone fragment from a Spanish cave, hiding a 6-year-old child's ear inside it, a child with Down syndrome who somehow survived years past when she should have died. A genetic study spanning 200,000 years, revealing not one meeting between these two kinds of humans, but 3. The evidence no longer merely suggests contact, it suggests family. We will not claim more than the evidence allows. Some of what follows is settled fact, confirmed by multiple independent teams. Some of it is a strong argument still being tested, and some of it remains genuinely unresolved, and this documentary will say so plainly, every time. The truth does not need exaggeration here. It is already almost unbelievable enough on its own. Before we continue, consider this. Somewhere in your own family's past, a choice was made about who cared for a child that was not entirely their own to raise, whether through adoption, a step-parent's love, or a grandmother who simply refused to let a grandchild go without help. Has your family ever done this? Tell us in the comments below. You may be closer to this 100,000-year-old story than you think. Now let us go back to where it truly begins, on a ridge above the sea, in 2 caves that would take a century to give up their secret. Chapter 1. The Caves on Mount Carmel. In the late 1920s, a team of archaeologists began digging into a cave on Mount Carmel, a limestone ridge that rises above the coastal plain of what is now northern Israel. The cave was called School. A short distance away, near the town of Nazareth, another team worked a second cave, Kafza. Neither site looked especially promising at first. They were simply caves, the kind that dot the Levant by the hundreds, worn into rock over hundreds of thousands of years by wind, water, and the passage of animals and people. What the archaeologists found inside changed the way an entire century of scientists would think about human origins, and it took most of that century to understand what they had actually found. At school, the excavators uncovered the remains of at least 10 individuals. At Kafse, they eventually recovered the remains of at least 15 more. These were not scattered bones washed in by chance. Many of the bodies had been placed deliberately, with a sense of position and care that archaeologists recognized immediately as burial. One individual at school was found with the jaw of a wild boar, cradled against his chest, placed there by someone who wanted to leave that animal with him. At Kafse, one child, catalogued by researchers as Kafse 11, roughly 12 or 13 years old, was laid in a specially shaped recess in the rock, her body arranged in a careful, curled position, with deer antlers placed over her pelvis. These antlers had no practical use in a grave. They could not have arrived there by accident. Someone selected them and placed them. Later analysis of the Kafse burials uncovered a further, quieter detail. Researchers examining shell remains recovered from the site identified perforated marine shells, deliberately pierced, showing wear patterns consistent with having been strung and worn, and in some cases stained with red ochre pigment, the same mineral later found in far greater quantities at Tinshemet Cave. These shells had been carried inland from the coast, evidence of either direct travel or a network of exchange reaching well beyond the immediate area around the burial caves. Combined with the antlers placed over the Kafse child's body, this points toward a community that marked its dead not simply with burial, but with objects that carried some form of chosen, symbolic meaning. Decades before symbolic ornamentation of this kind is conventionally assumed to have become a fixed part of human behavior anywhere in the world. The skeletons themselves puzzled researchers for decades. Some bones showed features that looked unmistakably modern: a high, rounded skull, a forehead that rose rather than sloped, a jaw with a proper chin. Other bones showed heavier brows, thicker limbs, more robust jaws, features associated at the time almost exclusively with Neanderthals. For years, some scientists proposed that the School and Kafse people were an intermediate population, a kind of bridge form between archaic and modern humans, and the group was even given its own scientific name suggesting a distinct type of early human. Dating only deepened the confusion. Early estimates placed the burials at around 40 to 50,000 years old, an age that would have made them roughly contemporary with the classic Neanderthal sites of Europe, tidy and easy to explain. But newer dating methods, including thermoluminescence testing on burnt flint and electron spin resonance testing on tooth enamel from animals found in the same layers, pushed the true age back dramatically. The School and Kafse burials are now understood to date to somewhere between roughly 90,000 and 130,000 years ago, with the most likely range for the School burials falling between 100,000 and 135,000 years, and the Kafse burials dated to around 92,000 to 120,000 years old. That number matters enormously, because Neanderthals were also living in the Levant during that same span of time, at sites like Taboon and Amud, only a short walk away by the standards of a hunting group covering ground across a season. This meant that anatomically modern humans, people who looked essentially like us, had left Africa and reached the eastern Mediterranean far earlier than scientists had once believed. It also meant those modern humans arrived into a landscape that was not empty. Neanderthals had already been living in the same region for tens of thousands of years before them, adapted to its caves, its seasonal rains, its herds of gazelle and fallow deer. The old, simple story. that modern humans marched confidently out of Africa around 60,000 years ago and swept the older human species aside, could not survive contact with these dates. The real picture was messier, slower, and far more human. Two different kinds of people appear to have shared the same narrow stretch of land, on and off, for an extraordinarily long stretch of time, perhaps 20,000 years or more in that region alone, long before either group had any idea their meeting would ever be studied by anyone. Modern genetic analysis has confirmed part of this picture with startling precision. Researchers who traced Neanderthal ancestry in the genomes of thousands of living people, alongside dozens of ancient genomes, found that non-African populations today typically carry between 1 and 2% Neanderthal DNA, a legacy from interbreeding that occurred as modern human groups expanded into regions Neanderthals already occupied. Some recent modeling using large samples of both ancient and modern genomes has narrowed the timing of a major shared period of gene flow to a window consistent with modern humans and Neanderthals living side by side in Eurasia for roughly 6,000 to 7,000 years before that mixing became embedded permanently in later human populations. That is not a single encounter. 6,000 to 7,000 years is longer than the entire span of recorded human history since the first cities were built. It is not one meeting in one valley. It is generations meeting generations, children growing up and having children of their own, all while both kinds of humans remained present on the same landscape. None of this proves, on its own, that Neanderthals and modern humans raised children together in a shared household or a shared camp. Living in the same region for thousands of years is not the same as raising a child side by side around the same fire, but it establishes something essential that the rest of this investigation depends on. The two groups were not separated by oceans or continents during the critical period when interbreeding happened. They were separated, at most, by a few days' walk, in caves that sit close enough that a person standing at the mouth of one can sometimes see the ridge that holds the other. Whatever happened between them happened close. The stone tools recovered from Skul and Kafsa add a further, physical layer to this picture. Both sites contain examples of what archaeologists call the Levallois technique, a method of stone tool production first identified in 19th century France that involves carefully shaping a stone core so that a single, precisely controlled strike detaches a flake of a predetermined size and shape. For much of the 20th century, researchers treated Levallois technology as a marker capable of distinguishing different populations from one another. That distinction has not held up under closer examination. The exact same core preparation method appears at Neanderthal sites throughout Europe and at modern human sites throughout the Levant and North Africa, including Skul and Kafsa themselves, where researchers have found this technology in use among some of the very earliest modern humans recovered outside Africa. A 2021 study led by researchers at the University of Kent, re-examining the archaeological record across this transition period, found that these related technologies overlapped in use for more than 100,000 years, considerably longer than earlier models of a rapid, clean cultural changeover had assumed. The overlap runs in the opposite direction as well. A 2021 study published by researchers examining a site in Saudi Arabia identified a specific variant of this technology called Nubian Levallois, a form long assumed to be a distinctly modern human innovation, in direct physical association with Neanderthal fossil remains, the first confirmed instance of Neanderthals using this specific method. The researchers who made the discovery were direct about what it meant. A technology researchers had used for years as a shorthand marker for identifying modern human presence at a site could no longer be treated as an exclusive marker of any single population. The debate has not fully settled, and honest reporting on this subject requires saying so. At Grotte du Renne in Arcy-sur-Cure, France, and at the nearby site of Saint-Césaire, researchers recovered a more advanced tool industry known as the Châtel-Perronian, alongside Neanderthal remains, raising a genuine scientific question about whether Neanderthals had independently developed sophisticated blade technology on their own, or had learned the technique through contact with modern human groups arriving in the region, an idea researchers call the acculturation model. Later reanalysis of the stratigraphy at Saint-Césaire cast doubt on whether the Neanderthal skeleton found there was ever reliably associated with the Châtel-Perronian tools in the same layer, and the debate over the industry's true origin, whether independent Neanderthal innovation or the product of contact with modern humans, remains actively unresolved among specialists in the field today. Rather than settling the question, this disagreement reinforces the deeper point this documentary has been building toward. Whichever explanation eventually wins out, both require sustained proximity and, in the acculturation model specifically, direct transmission of complex technical knowledge from one population to the other, the kind of transmission that, throughout human history, has typically depended on sustained personal contact rather than distant observation. To understand what that closeness actually looked like day to day, we need to leave Mount Carmel and travel roughly 40 kilometers north and east to a cave that has only recently begun to tell its full story. Tinchemet. Chapter 2. The Cave That Shared Everything. Tinchemet Cave sits in central Israel, and until recently it had not been excavated in any serious way for more than 50 years. When a team led by researchers from the Hebrew University of Jerusalem and Tel Aviv University began digging there in 2017, they were hoping to fill in a gap. What they eventually published, in a study that reached the public in the spring of 2025, did far more than fill a gap. It gave researchers their clearest single window yet into what daily contact between Neanderthals and modern humans may actually have looked like. The cave contains remains dated to between roughly 130,000 and 80,000 years ago, a period researchers call the Mid-Middle Paleolithic. Within that window, 5 human burials were recovered. The first burials from this specific time period found anywhere in the region in over 50 years. The bodies had been placed in a similar fetal position and buried with objects that had no practical purpose. Stone tools left beside the dead, animal bones set deliberately in the grave, and lumps of red ochre, a mineral pigment, included with the remains. The ochre is one of the most striking details. Analysis showed that some of it had been carried from sources up to 100 kilometers away. That is not an accident of geology. Someone walked, or someone traded, to bring that pigment to this specific cave for a purpose that had nothing to do with food or shelter. Researchers believe the ochre was most likely used to decorate the body, possibly to mark identity, group membership, or status, in a practice that appears at Tinchemet and also at the nearby caves of Skul and Kafze. When the same unusual behavior turns up at multiple sites across a region over a long span of time, it stops looking like an isolated event and starts looking like a shared tradition, one that different groups understood and followed together. What makes Tinchemet remarkable is not only the burials. The excavation team examined 4 separate categories of behavior at the site: how stone tools were made, how animals were hunted, how symbols and pigments were used, and how the group was organized socially. Across all 4 categories, the evidence pointed toward what the lead researchers called behavioral uniformity, meaning that whichever hominin group occupied the cave at a given time, whether Neanderthal, modern human, or a population showing traits of both, they were doing largely the same things, in largely the same ways. The animal bones recovered from the cave floor add a further layer of detail to this picture. Researchers identified cut marks on the bones of gazelle, wild cattle, and other game animals, showing consistent butchery patterns across the different occupation layers of the cave, regardless of which population had left the remains behind. This matters because butchery technique, much like tool production, tends to reflect learned tradition passed down within a group, the kind of practical knowledge a child would absorb by watching an adult work, repeated the same way across generations. Finding the same butchery patterns across layers associated with different populations suggests either that both groups arrived at very similar practical solutions independently, working with the same animals and the same available tools, or, as the excavation team has proposed, that this practical knowledge itself was being shared directly between the two populations, alongside their burial customs and their use of pigment. One of the excavation directors, Yossi Zeidner of the Hebrew University of Jerusalem, described the region during this period as a kind of melting pot, a place where different human populations met, interacted, and evolved together. His research partner, Marion Privok, has pointed out that the central question the team set out to answer was simple to ask and difficult to answer. Were Neanderthals and modern humans in this region rivals, peaceful neighbors, or something more deeply intertwined? The physical evidence from Tinchmet leans hard toward the third possibility. The clustering of burials in one place raises the further question of whether the cave functioned as something like an early cemetery, a location the group returned to specifically to bury their dead, which would imply not just contact between groups, but shared memory of place, shared ritual, and a level of social organization far beyond simple survival. This picture at Tinchmet does not stand alone. Roughly 200 kilometers to the northwest, on the Mediterranean coast of what is now southern Turkey, a separate excavation at a site called Uchazla II Cave produced findings announced in the summer of 2026 that reinforced the same conclusion from an entirely different angle. There, an international team spent 5 years excavating the cave layer by layer, recovering fossils, stone tools, animal bones and seashells, using the internal structure of fossilized teeth, a method that can distinguish Neanderthal dental growth patterns from those of modern humans even when a tooth is worn or fragmentary. The researchers were able to identify which group had occupied the cave during which period. Dating showed that Neanderthals used Uchazla cave from roughly 77,000 to 59,000 years ago. Homo sapiens then occupied the same cave from around 59,000 to 47,000 years ago. The two groups did not live in the cave at exactly the same moment, based on the current evidence. But the traces they left behind were, in the words of the research team, strikingly alike. Both groups hunted the same animals, both crafted stone tools using closely related techniques, both collected the same type of seashells, likely for ornamental or symbolic use. The researchers concluded that ideas and traditions likely passed between the two populations, meaning that even when they were not physically together in that exact cave, they were close enough and in enough contact through the wider region for knowledge to move from one group to the other. The cultural overlap between the two populations reaches deeper still into a category of behavior once considered the single clearest dividing line between Neanderthals and modern humans: art. For most of the 20th century, researchers treated symbolic image-making, painting, engraving, deliberate representation as proof of a uniquely modern human mind. That assumption held until 2018, when a team led by dating specialist Dirk Hoffman used uranium-thorium dating, a method that measures the decay of trace radioactive elements in mineral crusts that slowly form over cave paintings, to date red pigment markings in 3 separate caves across the Iberian Peninsula: La Pasiega, Maltravieso, and Ardales. The results, published in the journal Science, placed the paintings at a minimum of 64,800 years old, at least 20,000 years before modern humans are known to have arrived anywhere in Europe. The only population present in that region at that time was Neanderthal. A follow-up study at Cueva de Ardales, published by researchers including Maria Ángeles Medina Alcaide, went further, directly testing the chemical composition of the red pigment against natural mineral deposits found elsewhere inside the same cave. The pigments did not match the local geology, indicating they had been deliberately selected, likely mixed, and applied by hand rather than occurring naturally, and variations in the composition of different layers of paint corresponded to different ages, suggesting Neanderthals returned to this same cave repeatedly, over an extended span of time, to add to the same symbolic markings. Other sites have added further, independent confirmation. At La Roche-Cotard in France's Loire Valley, a 2023 study led by Jean-Claude Marquet identified deliberate finger-drawn patterns on soft cave walls dated to at least 57,000 years ago, in a cave containing no artifacts other than Neanderthal tools, making it effectively impossible for modern humans to have made the markings. At Gorham's Cave in Gibraltar, researchers recovered a deliberate cross-hatched engraving cut into bedrock, associated exclusively with Neanderthal stone tools and dated to at least 39,000 years ago. At a cave site in Krapina, Croatia, researchers recovered eagle talons bearing cut marks and polish consistent with having been strung together and worn as jewelry, dated to roughly 130,000 years ago, tens of thousands of years before any modern human presence in the region. Prehistorian William Rendu of the French National Centre for Scientific Research, reviewing this accumulating body of evidence, described it as a major contribution to redefining our understanding of Neanderthal culture, offering stronger evidence than ever before for a genuine Neanderthal capacity for abstract, symbolic thought. Taken together, Tinchamet, Ucharsleya Cave, and this growing catalogue of Neanderthal symbolic art describe something researchers had long suspected but rarely had the direct evidence to demonstrate: a shared cultural world stretching across the Levant, Anatolia, and Western Europe, lasting well over 100,000 years, in which two different kinds of humans were not simply aware of each other's existence, but were absorbing each other's methods, each other's symbols, and quite possibly each other's people. This is the world into which the disputed Skull-Eye child was born. Chapter 3. The Skull That Would Not Choose a Side. Return now to Mount Carmel, to the cave called Skull, where the first burials were pulled from the ground in the late 1920s and early 1930s by teams from the British Museum and the American School of Prehistoric Research. Among the 10 individuals recovered from that cave was a child, catalogued as Skull-Eye first, dated to roughly 120,000 to 90,000 years ago, among the oldest remains at the site. From the moment researchers first examined the Skull remains as a group, they struggled to agree on what they were looking at. The skulls combined features that, according to the standard textbook categories of the time, were not supposed to appear together. Some bones showed the rounded brain case, reduced brow ridge, and defined chin associated with modern Homo sapiens. Others showed the robust jaw, heavy brow, and large teeth associated with Neanderthals. Early researchers working within a framework that expected clean categories proposed that the entire Skull and Kafse population represented a separate, transitional type of human and gave it its own scientific name, a designation that has since been abandoned as later analysis confirmed the population was substantially modern, though unusually variable. The Skull-Eye child's skull sat at the center of that variability, and in a study re-examining the fossil, researchers identified a specific combination of features in the skull, jaw, and inner ear that they argued blended traits of both Homo sapiens and Neanderthals so closely that the most straightforward explanation was direct ancestry from both groups. If their interpretation holds, school I would represent the earliest known example of a child born to parents from each population, a physical, skeletal record of a Neanderthal, and a modern human family line meeting in a single individual, roughly 140,000 years ago by some estimates. It is essential, in the interest of honesty, to say plainly that this interpretation remains debated. Skull morphology, the shape and structure of bone, has been a notoriously unreliable guide to ancestry throughout the history of paleoanthropology, precisely because normal human variation, growth patterns, and even the process of fossilization itself can distort or exaggerate features that look diagnostic to one researcher and ambiguous to another. Other specialists who have studied the Skull and Kafza remains over the decades have argued that the mixture of traits reflects nothing more than the natural range of variation within an early, still diversifying population of modern humans, rather than evidence of two distinct species interbreeding. The debate has not been resolved, and it may never be resolved through skeletal analysis alone, since Skull is far too old for the kind of ancient DNA testing that has settled similar questions in more recent fossils. What can be said with confidence is this: the genetic evidence for interbreeding between Neanderthals and modern humans is not in doubt. It has been confirmed independently by multiple research teams, using different genomes, different statistical methods, and different fossil samples, going back to the first draft sequencing of the Neanderthal genome in 2010. That original study, led by Svante Pääbo's team at the Max Planck Institute for Evolutionary Anthropology, compared the newly reconstructed Neanderthal genome against DNA from 5 modern humans representing different world regions, and found that Europeans and Asians shared measurably more genetic material with Neanderthals than sub-Saharan Africans did, a pattern that made sense only if some interbreeding had occurred after modern humans began leaving Africa, but before they spread across Eurasia. Pääbo would go on to receive the Nobel Prize in Physiology or Medicine in 2022 for this body of work. Recognition that a discovery once considered nearly unthinkable, that 2 distinct human lineages had exchanged genes rather than remaining strictly separate, had become one of the most firmly established findings in all of paleoanthropology. Non-African populations today carry measurable Neanderthal ancestry, typically between 1 and 2% of their genome, though certain Levantine and southern Arabian populations, likely reflecting proximity to the original zones of contact, show levels running higher, in some analyses reaching between 1 and 4%. That interbreeding did not happen in the abstract. It happened between actual people, in actual places, most likely including the region around Mount Carmel and the wider Levant, where the geography, the climate, and now the archaeology all point towards sustained, overlapping habitation. Whether Skull himself was one of the direct products of that mixing remains an open, contested question, and this documentary will not claim more certainty than the researchers who study the fossil claim for themselves. But the child's skull, whatever its precise origin, sits as a physical symbol of something the genetic record proves happened somewhere, to someone, during this exact period, in this exact region. 2 kinds of humans, close enough to raise families near each other, were in some cases close enough to raise a family together. It helps to understand why skeletal evidence alone struggles so badly with questions like this one. A skull is built from dozens of separate measurements: the angle of the forehead, the thickness of the brow, the shape of the jaw, the depth of the eye sockets, the structure of the inner ear. In a population with 2 distinct ancestries mixing over generations, these measurements do not blend evenly. the way paint colors mix into a single new shade. Instead, a child might inherit a Neanderthal-shaped jaw from one grandparent and an entirely modern set of teeth from another, producing a skull that looks, to the human eye, like a patchwork rather than a smooth intermediate form. This is precisely the pattern researchers have struggled with at school and CAFSE for nearly a century, and it is also precisely the pattern predicted by modern hybridization genetics, where the traits of two source populations reassort semi-randomly in each subsequent generation rather than averaging together. The confusion earlier researchers felt when they first examined these skulls, unable to decide whether they were looking at a distinct species or simply unusual individuals, may itself be indirect evidence that mixing between populations was already underway in this exact region by the time these people lived. If that happened, even once, a harder question follows immediately behind it. A child born to a Neanderthal parent and a modern human parent does not raise itself. Somebody fed that child. Somebody protected that child through its most vulnerable years. Somebody decided, consciously or not, that this child belonged, regardless of which group its features most resembled. To understand whether that kind of care was possible, we need to look at how Neanderthals treated their own most vulnerable children, because the evidence there is far less contested and far more moving than anything found in a single disputed skull. Chapter 4. The Child Named Tina. In 1989, archaeologists working at Cova Negra, a cave near the town of Sativa in the Valencia region of eastern Spain, recovered a set of animal bones during a routine excavation season. The cave itself was already well known. Neanderthals had used it, on and off, from roughly 273,000 years ago to around 146,000 years ago, leaving behind stone tools and the remains of countless meals. The animal bones from 1989 were catalogued, stored, and largely forgotten for over 3 decades. In the early 2020s, a team led by Mercedes Conde Valverde of the University of Alcalá and Valentín Villaverde of the University of Valencia went back through that stored material, sorting through the faunal remains with fresh eyes. Among the animal bones, they found 3 small fragments of human bone that had been misidentified or simply overlooked. One fragment, given the catalogue number CN46700, was a piece of a child's temporal bone, the part of the skull that houses the inner ear. Using microcomputed tomography, a scanning method that let them build a detailed 3-dimensional digital model of the bone's internal structure without damaging the fragile fossil, the researchers examined the child's inner ear in extraordinary detail. What they found was a set of abnormalities that, in a modern child, would point clearly toward Down syndrome. The lateral semicircular canal, a structure involved in balance, showed an unusual dilation and reduced size. Another canal showed an underdeveloped bony structure. There were signs of an enlarged vestibular aqueduct and a small abnormal channel connecting 2 parts of the inner ear. Taken together, the researchers concluded this child had almost certainly suffered from a congenital inner ear pathology consistent with Down syndrome, one that would have caused, at minimum, severe hearing loss and significantly impaired balance. The team was able to estimate the child's age at death using a separate feature of the temporal bone, a small canal that changes shape predictably as a child grows. Based on that method, the child, whom the researchers affectionately nicknamed Tina, had lived to at least 6 years of age. That number is the heart of this chapter, because 6 years is not a small number in this context. In prehistoric populations, without modern medical support, children with the pathology found in Tina's inner ear typically did not survive long past infancy, and certainly not to the age of 6. The researchers were direct about what this implied in their published findings. A child with this condition would have needed continuous, intensive support for years, help with balance and mobility, help with communication given the hearing loss, and very likely, given the demanding, mobile lifestyle Neanderthal groups are known to have followed, more support than a single mother could reasonably provide on her own, while also hunting, gathering, and caring for other needs of daily survival. It is worth pausing on exactly why balance and hearing loss would have made Tina's situation so precarious in a way that modern readers, living in a world of paved floors and predictable terrain, may not immediately appreciate. Cova Negra sits in rugged, uneven terrain, and Neanderthal groups using the cave moved regularly across steep slopes, loose rock, and river valleys in pursuit of game and seasonal plant foods. A child with significantly impaired balance would have struggled simply to keep pace with a moving group across this landscape, let alone to navigate it safely alone. Combined with reduced hearing, which would have limited her ability to detect an approaching predator, a falling rock, or a shouted warning from another member of the group, her survival past infancy required not just occasional help, but essentially constant, attentive supervision, the kind that a single overstretched caregiver, already responsible for gathering food and managing other demands of daily survival, could not plausibly have sustained alone for 6 full years. The researchers wrote that this child's survival could only have occurred because she received continuous care and attention over an extended period, very likely requiring help from other members of the group beyond her mother alone. In an environment where every able adult's labor mattered for the survival of the whole band, choosing to devote sustained effort to a child who could offer little in return, at least by any transactional measure, points towards something researchers describe as genuine pro-social behavior, care given not because it was owed, but because the child was a member of the group, and the group chose to keep her. This finding did not appear in isolation. It joined a body of evidence, built up over decades, showing that Neanderthals extended care to members of their group who could not fend for themselves. And the most famous example of that evidence comes not from a child, but from a grown man buried in a cave more than 3,000 kilometers away. Chapter 5. The Man Who Should Not Have Survived. In 1957, excavators working at Shanidar Cave in the Kurdistan region of northern Iraq uncovered the remains of a Neanderthal man who has since become one of the most studied individuals in the entire fossil record. He is known simply as Shanidar I. He died somewhere between the ages of 35 and 50, at a time period researchers place between roughly 45,000 and 70,000 years ago, and by the standards of his environment he should not have lived nearly that long. His skeleton tells a story of accumulated severe injury. A crushing blow to the left side of his face, sustained sometime in his youth, had likely caused partial or complete blindness in one eye. His right arm ended in a clean break just above the elbow, evidence consistent with an amputation, whether from injury, infection, or deliberate intervention, that left him without the use of that limb for the remainder of his life. His leg bones showed signs of significant trauma, affecting how he walked, and later analysis identified degenerative bone changes consistent with a condition that causes muscular pain and reduced mobility along the spine. Then, in 2017, a fresh analysis, led by Eric Trinkhaus of Washington University in St. Louis, working with Sébastien Villot of the French National Center for Scientific Research, identified something earlier researchers had missed entirely: bony growths in both of Shanidar I's ear canals, severe enough to have caused major hearing loss, very likely near total deafness, for years before his death. Consider what that combination means in practical terms. A man missing most of one forearm, functionally blind in one eye, struggling to walk without pain, and, on top of all of that, unable to hear approaching danger, unable to easily coordinate with others during a hunt, unable to participate fully in the kind of group communication that a small band moving through unpredictable, predator-filled terrain depended on for survival. Trinkhaus and Villot were blunt in their assessment. His hearing loss alone would have made him easy prey for the large carnivores that shared his environment, and left him dependent on the people around him simply to stay alive. He stayed alive anyway, for years, possibly for a decade or more after his injuries. That fact alone tells researchers something Shanidar I's bones could never say in words. Somebody hunted for him when he could not hunt effectively himself. Somebody watched for danger on the side he could no longer see or hear. Somebody, over an extended period, decided that his life was worth the ongoing cost of protecting it. Shanidar I is not an isolated case. At a cave site called Baux de l'Aubercier in France, researchers identified an older Neanderthal individual who had lost most of his teeth long before death, a condition that, on its own, could have made eating solid food nearly impossible without some form of dietary support from others. At La Chapelle-aux-Sens in France, a Neanderthal known to researchers as the Old Man showed signs of severe degenerative arthritis, evidence of a body that had been in decline for years yet had continued to be fed and sheltered by those around him. Supporting individuals like Shanidar I, or the toothless elder at Baux de l'Aubercier, or the disabled child Tina at Cova Negra, required more than compassion alone. It required a food supply large and reliable enough to feed group members who could contribute little or nothing toward gathering it. Archaeological evidence recovered from Neanderthal hunting sites shows that this capacity existed, and on a larger scale than researchers once assumed. At 3 separate sites on the North European plain, dated to roughly 125,000 years ago, researchers have documented the systematic hunting and butchery of straight-tusked elephants, the largest land mammals of the Ice Age, animals that could weigh over 10 tons and provide, by some estimates, enough meat and fat to feed a substantial group for weeks. A single successful hunt of this scale, researchers examining the butchery marks concluded, would have produced far more food than any single family could consume before it spoiled, strongly suggesting that Neanderthal groups either operated in larger temporary gatherings than previously recognized, or had developed some capacity to preserve and store surplus food for later use, or both. A separate line of evidence reinforces the picture of genuinely coordinated, cooperative hunting rather than solitary opportunism. At a site in Germany, researchers led by archaeologist Sabine Gaudzinski-Windhäuser identified puncture wounds on the bones of ancient horses, made by wooden spears thrust at close range, evidence the team described as among the oldest confirmed hunting injuries in the entire hominin record. Bringing down a horse or similar large animal at close range, using a thrusting rather than thrown weapon, is not a task one hunter accomplishes alone with any consistency. It requires multiple hunters working in coordinated roles, driving prey toward waiting companions, closing off escape routes, and striking in sequence. Gaudzinski-Windhäuser noted that findings like these carry direct implications for understanding Neanderthal social structure, since successful, repeated cooperative hunts of this kind depend on hunters who can rely on each other, communicate a plan, and follow it under pressure. Isotope analysis of Neanderthal bone collagen across dozens of sites in Europe, conducted independently by multiple research teams, confirms the outcome of this hunting strategy. Neanderthals functioned, chemically speaking, as top-level carnivores, drawing nearly all of their dietary protein from large herbivores, a pattern that held remarkably consistently across tens of thousands of years and across widely separated regions. Producing that much meat reliably, generation after generation, required exactly the kind of group coordination, food sharing and provisioning capacity that made it possible for a Neanderthal band to carry a blind, one-armed, deaf man like Shanidar I or a severely disabled 6-year-old like Tina without that individual's presence threatening the survival of the group as a whole. The same infrastructure of shared, cooperative labor that let Neanderthals bring down an elephant also let them keep their most vulnerable members alive. Researchers who study this pattern remain genuinely divided on what it means at the deepest level. Some argue that this kind of care operated on a basis of reciprocity, extended mainly to individuals who had previously contributed to the group and could reasonably be expected to contribute again, or whose survival benefited the group in ways not immediately obvious. Others argue that the pattern goes beyond calculation and reflects something closer to what we would recognize today as compassion, a willingness to support a member of the group, regardless of whether that support would ever be repaid. The case of Tina, the child from Cova Negra, complicates the reciprocity argument considerably because a 6-year-old with a severe congenital disability had no prior contribution to point to and no realistic prospect of becoming self-sufficient enough to repay the group's investment anytime soon. If Neanderthals cared for her anyway, purely because she was one of theirs, then the same underlying instinct, the willingness to extend protection and resources to a vulnerable child, regardless of what that child could offer in return, becomes directly relevant to the central question of this documentary. A group capable of sustaining that kind of care for its own disabled children was, at minimum, psychologically and socially equipped to extend similar care to a child who did not look entirely like everyone else in the camp, including, potentially, a child born of a Neanderthal parent and a modern human parent, or a modern human child who had, for whatever reason, come to be raised among Neanderthals, or the reverse. To understand just how similar these two kinds of childhood truly were, day to day, we need to look at something even more intimate than burial customs or care for the disabled. We need to look at how Neanderthal mothers fed their infants, because that evidence, preserved in the growth rings of a child's tooth, turns out to be almost indistinguishable from our own. Chapter 6. What a Tooth Remembers. A tooth grows the way a tree grows, laying down thin layers day by day as it forms, each layer capturing a faint chemical record of what was happening in the child's body and environment at that exact moment. For most of the history of paleoanthropology, this record sat unread, because nobody had a method precise enough to extract it. That changed over roughly the last 15 years, largely through the work of biological anthropologist Tanya Smith, now at Griffith University in Australia, who developed techniques to measure both the physical growth lines in tooth enamel and the trace chemical elements embedded within those layers, at a resolution fine enough to identify events separated by only a matter of weeks. Smith and her colleagues applied this method to molars from 2 Neanderthal children found at the Peyre site in the Rhône Valley of southeastern France, dated to roughly 250,000 years ago, alongside a modern human child's tooth from a much later burial at the same location. Using a specialized ion microprobe, the team tracked weekly shifts in oxygen isotopes, which reflect seasonal temperature, alongside levels of barium, an element that spikes in a nursing infant's teeth because it concentrates in breast milk and is passed to the child during feeding. The results, published in Science Advances, allowed the researchers to reconstruct, almost month by month, the early life of a Neanderthal child who had died 250,000 years ago. One child, catalogued as Peyre 6, was born in spring, based on the oxygen isotope pattern, and continued nursing steadily until roughly 2.5 years of age, when the barium levels dropped sharply and stayed low, indicating the child had been weaned that autumn. That weaning age, 2.5 years, sits squarely within the normal range documented in modern hunter-gatherer societies studied by anthropologists today. The same study identified something else, something harder to read without a trace of sadness. The tooth also recorded a period of significant physiological stress at around 700 days of age, roughly the child's second year, likely reflecting illness, and separately, 2 distinct episodes of lead exposure, the earliest documented cases of lead exposure found anywhere in the human fossil record, most likely absorbed from contaminated food, water, or smoke near natural lead deposits close to the site. A Neanderthal mother, in other words, nursed her child through a serious illness, in a landscape that was quietly poisoning him, during winters that Smith's broader research on this site showed were often bitterly cold. She did this the same way any mother would. Later studies extended this picture further. A separate analysis of Neanderthal milk teeth from northeastern Italy found that weaning in some individuals began even earlier, around 5 to 6 months of age, closely matching typical patterns among modern human infants and suggesting broadly similar energy demands during early infancy across both populations. And in 2017, a team led by Antonio Rosas at Spain's National Museum of Natural Sciences published a detailed study of a young Neanderthal skeleton from El Cidron Cave, a boy known as El Cidron J1, who died a few months before his 8th birthday, roughly 49,000 years ago. The El Cidron J1 skeleton, remarkably complete, allowed the researchers to reconstruct his growth pattern in detail, his height, his weight, the development of his bones and teeth, even the wear patterns on his teeth suggesting he used them, as many people historically have, as a kind of third hand for processing animal hides and plant fibers. What the researchers found was that his overall pattern of growth closely mirrored that of a modern human child his age, with slow, extended development between weaning and puberty, the same energetically expensive growth pattern long thought to be connected to supporting a large, slow-maturing brain. The one clear exception was his chest, which was less developed than would be expected for his age, more consistent with a modern child of 5 or 6, a detail researchers suggest may reflect either a genuine species difference in the pace of certain aspects of physical development, or simply the ordinary range of individual variation found in any population, modern or ancient. Genetic analysis on the remains at El Cidron was even able to identify who the boy's mother was among the group, and confirmed that he had a younger brother among the same set of remains, evidence of an actual Neanderthal family unit, parent and children, recovered together from a single cave. Put all of this together, and a very specific, very human picture comes into focus. Neanderthal infants nursed for roughly the same length of time as human infants in traditional societies today. Neanderthal children grew through a long, slow childhood, remarkably similar in shape and pace to our own. Neanderthal mothers nursed their children through sickness, through winter cold, through environmental hazards, exactly as human mothers have always done. Neanderthal groups protected children with severe disabilities well past the point where a single caregiver could have managed alone, and protected injured or disabled adults for years after they stopped being able to contribute in traditional ways. None of this, by itself, proves that a Neanderthal parent and a modern human parent ever raised a child together in the same camp. But it dismantles, piece by piece, every assumption that would have made such a thing seem implausible. If Neanderthal childhood looked this similar to modern human childhood, in timing, in intimacy, in vulnerability, and in the depth of care a group was willing to invest, then the two populations were not raising children in two different emotional worlds that happened to overlap geographically. They were raising children, by every measurable standard available to science, in essentially the same way. The next question is whether that similarity ever became something more direct. whether in the specific overlap zone where both populations lived close enough to share tools, share burial customs, and in at least one debated case, produce a child, they also shared the day-to-day work of raising that child once it was born. Chapter 7. 3 meetings, not one. For most of the 20th century, when scientists discussed contact between Neanderthals and modern humans, they generally imagined a single event, one moment, one migration, one wave of modern humans moving into a landscape Neanderthals already occupied, with whatever mixing occurred happening once, briefly, before the two populations went their separate evolutionary ways. That picture has not survived contact with the genetic evidence gathered over the past several years, and the way it has fallen apart tells us something crucial about how deep and how repeated the relationship between these two populations actually was. In 2025, a team led by population geneticist Joshua Akey at Princeton University, working with Liming Li at Southeast University, published an analysis using artificial intelligence-assisted genetic modeling to trace gene flow between Neanderthals and modern humans across a span of roughly 200,000 years. Rather than looking only for Neanderthal DNA inside modern human genomes, the way most earlier studies had, Akey and Lee's team also searched Neanderthal genomes for segments of modern human DNA, effectively reading the exchange in both directions at once. What they found reshaped the timeline entirely. Instead of one contact event, the data pointed to at least 3 distinct waves of gene flow between the two populations. The earliest wave occurred roughly 200,000 to 250,000 years ago, a period far earlier than most previous estimates had considered, and one that would place contact between the two lineages close to the very origins of anatomically modern humans in Africa. A second wave followed roughly 100,000 to 120,000 years ago, a window that lines up strikingly well with the period represented by the School and Kafse burials on Mount Carmel. The third and largest wave, the one responsible for most of the Neanderthal ancestry carried by non-African populations alive today, occurred around 50,000 to 60,000 years ago. 3 separate windows of contact, spread across 200,000 years, are not consistent with a single accidental meeting between two populations that otherwise avoided each other. They are consistent with sustained, repeated, generational contact across an enormous span of time, in multiple regions, under different climatic and demographic conditions, each time producing children who carried the ancestry of both populations forward. Climate itself appears to have shaped exactly when and where these meetings became possible. Neither Neanderthals nor modern humans moved across the ancient landscape at random. Both populations followed the shifting boundaries of climate zones that could support the plants and animals each group depended on for survival, and those boundaries moved dramatically as the planet cycled between colder glacial periods and warmer interglacial ones. Researchers using ecological niche modeling, a technique that reconstructs where a species could plausibly have lived based on the climate and terrain preferences visible in its known archaeological sites, have identified the Zagros Mountains, a range stretching across what is now western Iran and northern Iraq, as a probable meeting corridor during the second wave of contact identified in the genetic record, roughly 100 to 120,000 years ago. During this period, the Zagros Range appears to have functioned as a natural bridge connecting two much larger ecological zones, allowing modern human populations to push northward and Neanderthal populations to push southward into the same overlapping territory at the same time, drawn together not by chance, but by the same favorable, resource-rich conditions. A separate climate study examining ancient rainfall records preserved in cave mineral deposits across North Africa identified a specific wet period between roughly 52,500 and 50,500 years ago that closely matches the timing of the third and largest wave of genetic mixing between the two populations. During this window, increased rainfall would have made the normally difficult desert terrain separating Africa from the Levant considerably easier to cross, effectively opening a temporary corridor for modern human groups moving directly into territory Neanderthals already occupied. The researchers who identified this pattern proposed that this wet phase may represent the first real opportunity for large-scale contact between the two populations in this region, a narrow climatic window during which two kinds of humans who might otherwise have remained separated by hostile terrain were instead drawn into the same valleys, the same water sources, and, ultimately, the same family lines. This same research helped resolve another long-standing puzzle: the strange, persistent shortage of Neanderthal DNA on the human X chromosome compared to the rest of the genome, a pattern researchers had struggled to fully explain for years. By refining estimates of Neanderthal population size using the newly identified modern human DNA embedded within Neanderthal genomes, Akey's team found that Neanderthal populations were considerably smaller than earlier estimates had suggested, likely only a few thousand breeding individuals scattered across their entire range at any given time. It is worth noting that this specific piece of the analysis, the interpretation of X chromosome ancestry patterns as evidence of biased mating between Neanderthal males and modern human females, has drawn direct scientific challenge. Other researchers analyzing the same class of genomic data have argued that the signal may instead be explained by genetic drift within an already small, declining Neanderthal population, rather than a true sex-based pattern in who mated with whom. This disagreement remains unresolved, and it illustrates something important about all of the genetics discussed in this documentary. Even the most sophisticated modeling still requires careful, contested interpretation, and responsible science treats live disagreement as part of the process rather than something to be hidden. What is not disputed is the small overall size of Neanderthal populations, and what that smallness meant when set against the rapidly growing numbers of modern humans expanding out of Africa. A population numbering only in the low thousands, spread thin across Europe and Western Asia, meeting a modern human population that was, by comparison, considerably larger and still expanding, does not face a battle. It faces something closer to a slow tide. Chapter 8: The Tide That Never Fully Withdrew. For decades, the disappearance of the Neanderthals was framed, in both scientific literature and popular imagination, as an extinction, a decline and eventual vanishing, whether from violent conflict with modern humans, competition for the same limited resources, disease, catastrophic climate shifts, or some combination of all four. Each of those explanations has genuine evidence behind it, and none of them has been fully ruled out. But a growing body of research over the past 2 years has pushed a different, and in some ways gentler, explanation to the center of the conversation: that Neanderthals did not simply vanish, they were absorbed. Akey has been direct about this framing in his own public statements on the research. He has said he prefers not to use the word extinction at all, because his data suggests Neanderthal populations slowly shrank until the last survivors were folded, generation by generation, into modern human communities. In his description, modern humans were less like a conquering army and more like waves crashing steadily against a beach, not destroying it in a single violent act, but slowly, patiently eroding it away through accumulated, repeated contact over tens of thousands of years. This assimilation model, as researchers call it, was not actually new. It was first proposed in 1989 by anthropologist Fred Smith of Illinois State University, decades before genetic evidence existed to test it. Aki's newer genomic data, he has said, provides strong support for what Smith originally hypothesized on skeletal grounds alone. A separate, independent line of research reached a strikingly similar conclusion through a completely different method. In late 2025, a team of researchers, including computational chemist Andrea Amadei at the University of Rome Tor Vergata, built a mathematical model of population dynamics, using birth rate data drawn from modern hunter-gatherer societies to simulate what would happen if small numbers of modern humans repeatedly migrated into and interbred with existing Neanderthal populations over time. Their model showed that recurring, relatively small-scale immigration events, combined with ongoing interbreeding, could account for almost complete genetic replacement of the Neanderthal population within 10,000 to 30,000 years, without requiring any advantage in intelligence, tools, or violence on the part of modern humans. Simple demographic mathematics, the researchers found, was sufficient on its own. A smaller population, repeatedly mixing with a larger one, will statistically dissolve into that larger population over time, generation by generation, birth by birth, even if every single individual involved got along perfectly well. There is something important and easy to miss, buried inside that mathematical result. A model like this does not run on abstractions. It runs on individual reproductive events, meaning individual relationships, individual pregnancies, individual children born and raised. For the numbers in these models to work at the scale researchers describe, this could not have been a handful of isolated, unusual encounters. It required this kind of pairing, and the resulting births and childhoods, to have happened often enough, and consistently enough, across enough generations, to measurably reshape an entire species' genetic future. This reframes the central question of this documentary in a way that matters. We are not asking whether it is plausible that, on rare occasion, a Neanderthal parent and a modern human parent might have raised a child together. The genetic and demographic evidence increasingly suggests something stronger, that across the multiple separate waves of contact identified in the genome, this kind of family, however it was structured, however the wider group around it understood or accepted it, was not a strange exception. It was, in at least some regions and periods, a normal, repeated, expected part of how these two populations related to one another, common enough to leave a permanent, measurable signature in the DNA of billions of people alive right now, most of whom have never given it a second thought, which raises an uncomfortable question this documentary cannot avoid. If children were born from these unions, generation after generation, across 200,000 years, what happened to them, specifically, day to day? Were they raised by one group and rejected by the other? Were they raised jointly, moving between two different sets of relatives, two different sets of customs? Or, as the archaeology from Tinschmidt and School and Kafse increasingly suggests, did the distinction between the two groups simply matter far less, on the ground, in daily life, than it matters to us now, looking back from a world that has spent a century trying to draw a hard line between Neanderthal and modern human that the people actually living through this period may never have drawn quite so sharply themselves. Chapter 9. A species that never raised children alone. To understand how a Neanderthal parent and a modern human parent could realistically have raised a child together within a mixed group, it helps to step back and look at how modern humans raise children in general, because the answer is stranger and more relevant to this story than most people assume. Human infants are born extraordinarily dependent, more so than the infants of almost any other primate. A human baby cannot walk, cannot feed itself, cannot regulate its own body temperature reliably, and requires years of intensive investment before it can contribute meaningfully to its own survival, let alone the survival of the group around it. Raising a single human child to independence is, in energetic terms, an enormous undertaking. Researchers who study human evolution have long puzzled over how any single mother, or even a single mother and father together, could realistically have met that cost on their own, especially while also nursing, hunting or gathering, and caring for other children at different stages of dependency at the same time. The answer that has emerged from decades of anthropological research is that, among humans, they typically did not do it alone. Researchers call this pattern alloparenting, meaning care provided by someone other than the child's biological parents. It is not simply babysitting in the casual modern sense. Studies of living hunter-gatherer societies, including detailed field research among groups such as the Hadza of Tanzania and the Agta and Bayaka peoples in different regions, have found that infants and young children routinely spend substantial amounts of time in close physical proximity to caregivers who are not their biological mother or father, including grandparents, older siblings, aunts, uncles, and notably unrelated adults within the same camp, who have no direct genetic stake in that particular child at all. This matters enormously for the question this documentary is asking, because it means the boundary anthropologists have identified as most important to a young child's survival was never simply parent versus non-parent. It was insider versus outsider, member of the group versus stranger to the group. Evolutionary researchers, including biological anthropologist Sarah Blaffer-Hrdy, whose work on this subject has shaped much of the modern field, have argued that this capacity for cooperative, shared childcare among unrelated group members may be one of the defining features that allowed the human lineage to survive at all, given the sheer cost of raising such slow-developing, dependent offspring. One specific version of this cooperative caregiving has received particular attention from researchers trying to explain a genuine biological puzzle: why human women, alone among almost all mammals, routinely live for decades after their reproductive years have ended. Anthropologist Kristen Hawkes of the University of Utah, drawing on years of fieldwork among the Hadza people of Tanzania, proposed what has become known as the grandmother hypothesis. Her observation, made initially while watching older Hadza women spend long days digging for tubers, was that postmenopausal women were not idle dependents. They were often the most productive food gatherers in the entire camp, and the food they collected went disproportionately toward feeding their grandchildren, freeing young mothers to wean their own children earlier and have their next child sooner, without any reduction in the survival chances of the child already born. Hawkes and her colleagues have argued that this pattern, sustained across enough generations, could account for several otherwise puzzling features of human biology at once: our unusually long lifespan compared to other apes, our late age of physical maturity, and the specific timing of menopause itself, which leaves women with active, healthy decades of life, during which their labor benefits their existing descendants rather than new offspring of their own. The hypothesis remains genuinely debated within anthropology, and honest reporting requires saying so plainly. Critics have described it as difficult to prove or disprove definitively, a compelling story that fits the available data without being uniquely confirmed by it, and researchers continue to test it against alternative explanations for the evolution of human longevity. What is not in dispute is the underlying behavioral pattern documented repeatedly in living hunter-gatherer societies. Grandmothers, and more broadly, older group members past their most physically demanding years, routinely provide substantial, measurable childcare and food support to children who are not their own direct dependents in any immediate sense. Whether Neanderthals shared this same pattern depends on a question researchers have found surprisingly difficult to settle: How long did Neanderthals typically live? For decades, the rarity of elderly individuals in the Neanderthal fossil record led many researchers to assume a fundamentally shorter lifespan than modern humans. One contributing factor, some argued, in their eventual disappearance. A 2011 study by Eric Trinkhaus, the same researcher who identified the extent of Shanidar-1's injuries, directly challenged this assumption. Analyzing adult age distributions across the fossil record, Trinkhaus found roughly equal proportions of Neanderthal and early modern human remains falling into the 20 to 40 and over 40 age brackets, concluding that adult life expectancy was likely similar between the two populations, and that any demographic advantage modern humans held probably came from higher fertility and lower infant mortality, rather than Neanderthals simply dying younger. More recent work using an entirely different method has produced a more complicated picture. In 2019, researchers at Australia's National Science Agency developed a technique for estimating lifespan directly from ancient DNA, based on patterns of a chemical modification called methylation that accumulates in predictable ways as an organism ages. Applying this method to sequenced Neanderthal and Denisovan genomes produced an estimated typical lifespan in the high 30s, comparable to their estimate for early modern humans using the same method, though other researchers using different methylation-based approaches have argued for Neanderthal lifespan potential extending well beyond 60 years in at least some cases, closer to the outer range documented in modern human populations before industrial-era medicine. The disagreement between these methods has not been resolved, and it illustrates, once again, how much remains genuinely uncertain even in a period of rapid scientific progress. What both approaches agree on, however, is that at least some Neanderthal individuals lived long enough and remained active enough to have functioned as grandparents in the way Hawkes describes, past their years of peak physical labor, but still capable of gathering food, minding children, and passing down accumulated knowledge to a younger generation. Shanidar-1 himself, surviving into his late 30s or beyond despite catastrophic injury, stands as direct physical proof that at least some Neanderthal communities were both willing and able to sustain older, less physically capable members for years. If sharing the work of raising a child among unrelated adults within the same camp was already a normal, expected feature of how humans reared children, long before Neanderthals and modern humans ever crossed paths, then the specific question of whether a mixed group, containing both Neanderthal and modern human adults, could have jointly raised a child born from their union becomes considerably less exotic than it first appears. It would not have required inventing an entirely new kind of social behavior. It would only have required extending an already deeply rooted human pattern, sharing the burden and joy of raising children across a group, to include members whose ancestry crossed the line researchers today draw between two different populations, but which the people actually living in that camp may have experienced simply as their group, their family, their responsibility. There is direct archaeological support for exactly this kind of extended care appearing at the sites already discussed in this documentary. The case of Tina, the Neanderthal child from Cova Negra with a severe congenital condition, only makes sense as the product of alloparental support. Researchers explicitly concluded her survival to 6 years of age would have required help from other members of the group beyond her mother alone, because the demands of caring for her, combined with the demands of finding food and staying safe as a mobile hunting band, exceeded what one caregiver could realistically provide. The same logic applies to Shanidar-1, whose combination of blindness, missing forearm, and eventual deafness would have made him entirely dependent on sustained group support for years. These cases prove that Neanderthal groups were both willing and able to extend intensive, long-term, non-reciprocal care to vulnerable individuals within their group. The remaining question, the one genetics answers but archaeology can only gesture toward, is where the boundary of that group actually sat during the periods of contact identified at School, Kafse, and Tinchamet. If a Neanderthal group's sense of who belonged to them could stretch to include a severely disabled child who could offer nothing measurable in return, it becomes considerably easier to imagine that same group's sense of belonging stretching to include a child born of mixed ancestry, provided that child was recognized, from birth, as one of theirs. Cooperative childcare of this kind, spread across multiple adults within a group, depends on something easy to overlook: the ability to communicate clearly enough to coordinate it. A caregiver cannot hand a child's needs off to another adult, explain that a fever has worsened, or warn of danger approaching camp, without some functioning system of language. For decades, this was one of the strongest arguments used to separate Neanderthals from modern humans, built on the assumption that Neanderthals lacked the physical or cognitive apparatus for complex speech. That assumption has been steadily dismantled by physical evidence recovered from their own remains. In 1983, excavators at Kebara Cave in Israel recovered a nearly complete Neanderthal skeleton that included an intact hyoid bone, the small, horseshoe-shaped bone that anchors the muscles of the tongue and throat and plays a central role in producing human speech. The Kebara hyoid, dated to roughly 60,000 years ago, proved almost identical in shape and size to a modern human hyoid, a finding that surprised researchers who had expected a more primitive structure. A later study went further, using detailed computational modeling of the bone's internal architecture, the microscopic pattern of bone strengthened by repeated mechanical stress over a lifetime, and found that the Neanderthal hyoid had been loaded and used in a manner consistent with modern human speech production, not simply shaped like ours by coincidence. Genetic evidence added a second, independent line of support. In 2007, researchers at the Max Planck Institute for Evolutionary Anthropology successfully extracted and sequenced the FOXP2 gene from Neanderthal remains recovered at El Cidrón, the same cave that later yielded the detailed growth data on the young Neanderthal boy discussed earlier in this documentary. FOXP2 is the single gene most clearly linked to human speech and language ability. When a specific human mutation in this gene is disrupted, the primary effect observed is a severe impairment of language, largely without affecting broader intelligence. The Neanderthal version of FOXP2, recovered from El Cidrón, carried the same two mutations found in modern humans, mutations absent in chimpanzees and other primates, suggesting the genetic foundation for complex speech had already evolved in the common ancestor shared by both lineages, hundreds of thousands of years before Neanderthals and modern humans became distinct populations at all. Separate anatomical research examining the inner ear structures of Neanderthal fossils has reached a compatible conclusion, finding that Neanderthal hearing appears to have been tuned toward the same frequency range used in human speech, rather than the broader range typically associated with general environmental hearing alone. None of this proves Neanderthals spoke a language identical to any modern human tongue, and responsible researchers are careful to note that anatomy and genetics alone cannot fully settle questions about the complexity or grammar of Neanderthal communication. But the combined weight of the hyoid, the FOXP2 gene, and the inner ear evidence removes one of the last major objections to the idea that Neanderthals could coordinate complex cooperative behavior, including the kind of shared childcare already documented at Cova Negra and inferred at Shanidar. A group capable of spoken communication close in structure to our own was a group capable of explaining a child's needs to another adult, passing instructions across a camp, and building the kind of shared understanding that raising a vulnerable child whatever that child's ancestry has always required. Recent research on a separate and even more elusive population adds one more layer of evidence, suggesting that this kind of flexible, cross-group family structure was not unique to Neanderthals and modern humans alone. Chapter 10: The Third Parent No One Has Ever Seen. While this documentary has focused on Neanderthals and modern humans, the genetic record of interbreeding during this period is not limited to those two populations alone. A third group, known as the Denisovans, identified initially not from a complete skeleton, but from a single finger bone and a few teeth discovered in Denisova Cave in the Altai Mountains of Siberia, also interbred with both Neanderthals and modern humans during roughly the same broad span of time. Present-day populations in parts of Asia and, most strikingly, in Melanesia and among some indigenous peoples of Oceania carry measurable Denisovan ancestry today, in some populations reaching several % of the genome, a legacy of contact between modern human ancestors and Denisovan populations that researchers still cannot fully map onto specific archaeological sites, because so little physical trace of Denisovans as a population has ever been recovered. In 2012, archaeologists sifting through more than 2,000 unidentifiable bone fragments from Denisova Cave pulled out a sliver of bone no larger than a thumb tip. It carried no shape distinctive enough to identify by eye. It sat in storage until 2016, when a research team led by Samantha Brown screened the cave's fragments using a technique called zooarchaeology by mass spectrometry, a method that identifies the species of origin for a bone fragment from its collagen protein signature alone, without needing any visible diagnostic features. The fragment, catalogued as Denisova 11, tested as hominin. It was sent onward for full genetic sequencing. What the genome revealed, published in 2018 by a team led by Viviane Slon and Svante Parbo of the Max Planck Institute for Evolutionary Anthropology, stunned researchers across the field. The bone belonged to a girl who had died at approximately 13 years of age, roughly 90,000 years ago. Her DNA showed, in close to equal measure, ancestry from both a Neanderthal mother and a Denisovan father. She was not a distant descendant of mixed ancestry, several generations removed. She was a first-generation child, born directly to one parent from each population. Researchers nicknamed her Denny. To date, she remains the only first-generation hybrid hominin ever identified anywhere in the fossil record. Denny's genome held a second surprise. Her Denisovan father, the analysis showed, himself carried Neanderthal ancestry from an earlier interbreeding event in his own family line, dated to roughly 8 to 17,000 years before Denny's own birth. This means Denny was not simply the product of a single, isolated meeting between two otherwise separate populations. She was the product of at least two distinct episodes of mixing between Neanderthals and Denisovans, occurring generations apart, in or near the same general region. Her mother's own genetic signature, meanwhile, showed a closer relationship to Neanderthal remains recovered far to the west, at Vindija Cave in modern Croatia, than to the older Neanderthal population that had occupied Denisova Cave itself in earlier periods. This detail told researchers something unexpected about mobility. At least one Neanderthal lineage had travelled a very long distance across Eurasia, from somewhere near the Balkans to the Altai Mountains of Siberia, before Denny's mother was ever born. Denny's discovery matters enormously for the argument of this documentary, and researchers studying Denisova Cave have said so plainly. If a single small bone fragment, pulled essentially at random from a pile of thousands of unidentified scraps, happened to belong to a first-generation hybrid child, the statistical implication is not that this was a rare, singular event. It is that mixing between these populations, wherever their ranges overlapped, was likely common enough that similar children were being born repeatedly, and that Denny's remains simply happened to be the one example preserved well enough and tested carefully enough for science to recognize. As one recent academic analysis of the find put it, if one such child appears in a sample this small, the deeper history was very likely rich with other families like hers, their physical traces still waiting, unrecognized, in museum drawers and unsorted sediment across multiple continents. Whatever camp Denny was born into, in the foothills of the Altai Mountains 90,000 years ago, someone raised her past infancy and into her early teenage years, in a landscape shared, at various times across more than 200,000 years, by Neanderthals, Denisovans, and eventually modern humans as well, making Denisova Cave the only known site on Earth occupied by all three populations. Her survival to adolescence required the same nursing, the same protection through childhood illness, the same years of accumulated care already documented at Pear, at El Sidron, and at Cova Negra. She is the clearest single piece of physical evidence available anywhere in the human fossil record that children of mixed ancestry between archaic and modern human lineages were not simply born. They were raised, fed, kept alive, and allowed to grow up. Denny's case also offers a rare, direct answer to a question this documentary has had to leave open at almost every other site discussed so far. Not whether such children existed, but roughly how long they typically survived once they did. A single bone fragment cannot tell us whether she was raised primarily by Neanderthal relatives, Denisovan relatives, some combination of both, or an entirely mixed group whose ancestry no longer mapped cleanly onto either population by the time she was born. Her mother's genetic connection to Neanderthal populations recovered thousands of kilometers to the west, and her father's own inherited Neanderthal ancestry from a still earlier generation suggest a family history that had already been crossing these boundaries for some time before Denny herself was conceived, making her less a singular anomaly than a late data point in a genetic lineage that had been blending for multiple generations already. Researchers studying the wider Denisova Cave sediment record have noted that the site was occupied intermittently across more than 200,000 years by shifting populations of Neanderthals and Denisovans, with genetic and archaeological evidence suggesting repeated, if irregular, contact between them throughout that span, rather than a single, isolated encounter that happened to produce one unusually well-preserved bone fragment. The existence of this third population, and of a documented hybrid child within it, matters for the wider argument of this documentary because it demonstrates that interbreeding between distinct, long-separated human lineages was not a strange, isolated exception occurring in one unusual place. It was a broader pattern across the human family during this period, occurring wherever different populations came into sustained contact, from the Levant to Siberia to Southeast Asia. Wherever these populations met and mixed, children were born who carried the ancestry of both, and those children, by simple biological necessity, had to be raised by somebody in some kind of family or group structure, whether that structure was fully accepting, quietly tolerant, or something more complicated that has left no direct trace for archaeology to recover. This wider pattern gives us something valuable, a way to test whether the specific case of the Levant, with its unusually rich and unusually early evidence, is a true outlier in human history, or simply the clearest window we happen to have into something that was likely happening in a quieter and less well-preserved way across much of the ancient world during this long period of overlapping human populations. The evidence increasingly suggests the latter. The repeated waves of gene flow identified by Akey and Lee's team, spanning 200,000 years and multiple separate contact events, would be difficult to explain if mixing between Neanderthals and modern humans had been rare, socially forbidden, or limited to isolated, unusual circumstances. Demographic models built independently by other research teams arrive at the same conclusion from a completely different angle. For interbreeding to leave the genetic signature it has left in human populations today, it needed to happen often enough, and consistently enough, to matter at a population level, not once in a rare while, but as a recurring, ordinary feature of how these two kinds of people related to each other across dozens of generations. None of this evidence can tell us the emotional texture of any individual relationship, whether a specific Neanderthal father and a specific modern human mother loved each other, tolerated each other, or came together under circumstances we would recognize today as troubling rather than tender. Genetics and demography operate at population scale. They record outcomes, not intentions. This documentary has been careful throughout not to claim more certainty than the evidence supports, and that caution holds here as firmly as anywhere else in this story. What the combined evidence does support, clearly and repeatedly, across multiple independent sites and multiple independent scientific methods, is this: Neanderthal children were nursed, weaned, and grown through a long, slow childhood essentially indistinguishable from our own. Neanderthal groups protected vulnerable children and disabled adults with sustained, costly, non-reciprocal care. Neanderthal and modern human communities living in close regional proximity shared tools, shared burial customs, shared the same use of ochre, and very likely shared knowledge that passed directly between them. Children were born, repeatedly, across 200,000 years, carrying the ancestry of both populations, and the deeply rooted human pattern of raising children collectively, across a group rather than within a single isolated family unit, was already firmly in place among both populations long before any of this contact began. This ancient mixing did not stay locked in the past. It is present right now in the bodies of billions of people, in ways researchers have only begun to map in detail over the last 15 years. Geneticist John Capra at Vanderbilt University led one of the first large studies directly comparing Neanderthal DNA against modern clinical health records, examining tens of thousands of patients, and found that inherited Neanderthal gene variants influence a genuinely wide range of traits: skin's capacity to tan or burn, patterns of baldness, susceptibility to certain autoimmune conditions, and even some aspects of mood and tobacco dependence. A separate team at Harvard Medical School, led by geneticist David Reich, found that Neanderthal ancestry concentrates especially heavily in genes affecting keratin, the tough protein that gives skin, hair, and nails their structure, and speculated this may reflect a genuine adaptive advantage. Neanderthals had already spent hundreds of thousands of years adapting to the cold, low-light environments of Ice Age Europe and Western Asia before modern humans ever arrived there, and some of that hard-won adaptation appears to have passed directly into the modern human populations that inherited it. Not every inherited trait has been beneficial. The same body of research has linked Neanderthal-derived gene variants to increased risk for conditions including type 2 diabetes, Crohn's disease, lupus, and certain skin lesions caused by sun exposure. Other studies have found associations with sleep patterns and allergy risk. Yet, in at least one striking case, the inheritance appears to have been protective in an unmistakably direct, life-preserving way. Svante Parbo and his collaborators, analyzing genetic and medical data from roughly 244,000 women in the United Kingdom, found that women carrying a specific Neanderthal inherited gene variant were less likely to experience miscarriage or bleeding during pregnancy, and tended to have larger families as a result. a trait inherited from a Neanderthal ancestor. In other words, maybe helping some modern women carry their own children successfully to term today, tens of thousands of years after the original mixing between the two populations took place. It is difficult to imagine a more direct, more intimate thread connecting the ancient story this documentary has traced and the lived, present-day experience of families having children right now. Put together, these threads do not prove, with the certainty of a single unambiguous fossil, that any one specific Neanderthal parent and modern human parent stood side by side raising a specific child. But they make that scenario, repeated many times across many generations in the regions where the two populations overlapped, not merely possible, but, given everything we now know about how both populations actually lived, difficult to imagine not happening at all. Conclusion. Return for a moment to that hillside grave in northern Israel, to the small girl buried with deer antlers laid carefully across her body by someone who could not save her, but would not let her go without ceremony. Return to the disputed skull at school, the one whose jaw and inner ear refused to declare, once and for all, which side of an ancient boundary it belongs to. Return to Tina, the Neanderthal child from a Spanish cave who lived 6 years past the point where her body alone should have carried her, because the people around her chose, again and again, day after day, to carry her instead. Return, finally, to Denny, the 13-year-old girl in Siberia whose single fragment of bone proved, beyond argument, that a Neanderthal mother and a Denisovan father once had a daughter, and that daughter grew nearly to adulthood before the world took her too. These are not separate stories. They are fragments of a single, larger answer to the question this documentary set out to ask. Did Neanderthals and modern humans raise children together? The strongest, most responsible answer the evidence currently supports is this. In the specific regions and periods where these two populations lived close enough to share caves, share tools, share burial customs, and share the same rare symbolic use of ochre, for tens of thousands of years at a stretch, children were very likely raised in ways that did not respect the hard boundary later scientists would draw between one kind of human and another. The genetic record proves, beyond serious dispute, that interbreeding happened repeatedly across at least 3 separate waves spanning roughly 200,000 years. The archaeological record proves that both populations were capable of, and regularly practiced, the kind of sustained, costly, non-reciprocal care that raising a vulnerable child of any ancestry requires. And the deep anthropological pattern of shared, cooperative childcare, already documented as central to how humans in general have always raised their young, removes the largest remaining obstacle to imagining a mixed family folded into a mixed group, tended by whichever adults happen to be present and willing, regardless of which population each of them most closely resembled. What remains uncertain, and what this documentary has tried never to overstate, is the emotional and social texture of those specific relationships. Whether a given child born of both lineages was celebrated, quietly accepted, treated exactly like every other child in camp, or faced some version of the wariness that difference has provoked in every human society since, the physical evidence available today cannot say with certainty. Bones and teeth and stone tools can tell us that people survived, that they were fed, that they were cared for long past the point where cold calculation alone would predict abandonment. They cannot fully tell us what it felt like to be that child, or that parent, standing at the edge of 2 different human worlds that had, by every measure we can now recover, already begun to quietly become one. Perhaps that uncertainty is, in its own way, the most honest ending this story can offer. For most of the last century, Neanderthals were cast as the tragic, doomed cousins of modern humans, a separate species outcompeted and erased. The evidence gathered over the last 2 decades, and especially over the last 2 years, tells a different story, one considerably harder to summarize in a single dramatic sentence, and considerably more true to how families actually work. Not conquest, not replacement. A slow, patient, repeated meeting of people generation after generation, in caves above the Mediterranean, along the coast of Anatolia, and in the foothills of Siberia, until the line between one kind of human and another had been crossed so many times by so many families that it stopped functioning as a boundary at all. Consider, too, what this means for the word extinction itself, a word this documentary has used carefully and sparingly, because the evidence increasingly suggests it may be the wrong word entirely. An extinction implies an ending, a population that vanishes and leaves nothing behind but bones in the ground. That is not what the genetic record shows. Every person alive today, whose ancestry traces outside Africa, carries, on average, roughly the same proportion of Neanderthal DNA in every cell of their body that a great-great-grandparent would have contributed to their family tree. In a strict biological sense, the Neanderthal lineage did not end. It was folded into the population that survived. One relationship, one birth, one raised and protected child at a time, until it became inseparable from what we now simply call human. Somewhere in the deep, unrecorded past of nearly every person watching this documentary whose ancestry traces outside Africa, a Neanderthal parent and a modern human parent, or their descendants a few generations removed, made the same ordinary, extraordinary choices that parents have always made. They fed a child. They kept that child warm through a hard winter. They stayed near enough, for long enough, that the child survived to have children of their own. That is not a footnote to human history. Carried forward, one nursing, one illness survived, one small act of shared care at a time, it is a piece of how human history was made at all. The cave on Mount Carmel is still there. The deer antlers, carefully placed over a child who died 100,000 years ago, are preserved now behind glass, in a museum, far from the hillside where someone once knelt beside her grave and decided that this particular child deserved to be remembered. We will likely never know her parents' names, their species, or the exact shape of the family that mourned her. But we know now, with more confidence than any generation before us has had, that somewhere nearby, in caves not so different from hers, other children were being raised across the very boundary we once assumed could never be crossed. And in enough of those quiet, unrecorded moments, across enough winters, across enough generations, that boundary simply came undone,